Well, welcome to the second part. At the end of the first part, we'd created a brick wall and alternated every other row of bricks, and the result is what you see here. Now we need to fill in the gaps at the end of each of those alternated rows. Well, there are a number of possible ways of doing this, and this is one of them. I'm going to go back to our line, and I'm going to enable viewing points. We can see points on the line, and I'm going to create a group which I'm going to call end point, and I'm going to just select point number 0, and this is a point group, and if I enter $OS there, it's going to be called endpoint. So I've just selected point 0. Now, because of the way lines are constructed, point 0 is always going to be an endpoint. And the next thing I'm going to do is create another group. And this group is going to be not endpoints. So how am I going to create a group which contains everything apart from the endpoint? Well, the answer is in this Combine tab here. It's a point group. I'm going to take for the group name here $OS, so this is this group that we're creating. And for the other group, I'm going to take the one we created a moment ago, endpoint. The moment this equal sign means that the group we're creating here, not endpoints, is identical to this group. It contains all the points in here, i.e. just the endpoint. If, however, I change this to not equals, it will contain all of the points except the points that are in here. Now, let's lay out our network. So we've got two groups here. If I middle mouse over the top of them, we can see that the endpoint group has 1 point, as we expect, and the not endpoints has 10 points. What happens when we create the extra rows by duplicating these? Well, in fact, the group properties are carried over, so we end up with 7 points in endpoint and 70 points in not endpoints. So it's remembering which group the points are in and adding them as each copy is created. If we go back to our copy SOP, we can see that there is a field here called template group, and template group allows us to choose a subset of the points in the template to copy our bricks to. So in this case, I'm only going to copy the large bricks to things which are not the endpoint. And then we need a further copy SOP, and I'll enlarge this so that we can see it better, to copy our half bricks. So let's lay that down, and it's going to be the same template but with a half brick as the geometry. And what we want to do is copy this to endpoints, and that's giving us just those bricks there. And then I need to merge these together, so that we can see both at once. Now, that's not quite what we'd expected. First of all, there's an offset between these small bricks and the rest of them. And the reason for that is that, of course, the difference, the gap between the points here, is still the same as the length of this brick. So I need to adjust the endpoint, and I can do this here using a transform SOP. and I'm just going to adjust the endpoint, and the amount I need to adjust it by is in fact 0.25, and the reason it's 0.25 is because it's half the length of our half brick. So again, what I'm going to do is take the length of our half brick, copy the parameter, and in our transform I'm going to paste copied relative references, and I'm going to multiply it by 0.5. And now we can see that the bricks are correctly added to the end of those rows. But there's still something wrong here, because we're getting this offsetting and these gaps. So in order to make this look correct, we're going to need to rotate each alternate row so that it puts the half brick at this end here. Let's try doing that. So to rotate every alternate row, we need to insert a transform SOP underneath the group where we selected every alternate row, and in fact, of course, we've got one already here, so I can use that. This is offsetting each row. We also need to rotate each row by 180 degrees. Now that's not exactly what we expected, and the reason for that is that our center of rotation is here at the origin, and that's because our line here started at the origin and went off, and we need it to start at to be centered on the origin, and we can do that by copying this parameter, which is the distance covered, and putting it into the Z parameter here as a relative reference, and multiplying it by 0.5. And this should, let's turn the grid back on, sorry, that should be minus. This should ensure that our line is centered on the origin, and that's what's happening. So if we go back to this transform, we can see that it is now rotating correctly, and if I go back to the final node, we should see that the bricks are aligned, but they're not. And what's going on here? Well, the reason for this is that the copy SOPs are using point attributes to transform the bricks as they're copied, and because we're rotating the points in the alternate rows, we get this odd behavior. So we need to take this off both of our copy SOPs, and now we find that we have a brick wall with proper alternating rows. And because we've built this procedurally, we can change the number of rows, and we can do that quite simply using this. And we can change the number of bricks in a row like this, and it still works. And we can also change the size of a brick, and it still works. So that brings us to the end of this tutorial. In the next part we'll look at how to convert the wall into a rigid body glue object.